I can flip it anyway. If I can't, I'm just leaving this on, so I don't care. So the first problem we had is 7 pizzas, 11 people. Okay, 7 pizzas, 11 people. And we saw that the way to do this is, first of all, to divide them in half. So we can quickly give 11 halves. And that leaves 3 halves left over. And we want to divide those 3 halves among 11 people. So we'll divide those into 8ths of a pizza. And therefore, everybody ends up getting half a pizza plus, was it 1/8? Yeah? Okay. And there's 1/8 left over. Okay? Notice the fractions have a 1 in the denominator. So this is one reason given for the origin of Egyptian fractions.
Numerator.
Okay, numerator. Thank you, Craig. I'm sorry. Retake. Okay, take 2. All right, now. So these are Egyptian fractions. Egyptian fractions are only allowed to have 1 in the numerator. So this is how the Egyptians wrote fractions. They took the regular numbers, like say 3, and put a loop over them, and that meant 1/3. Okay? Because they wrote fractions like this, if they wanted to do 7/8, they had to decompose it into fractions. So Craig, you gave us a reason, a starting point for decomposing 7/8. What number did you start with?
Half.
A half.
1/2.
And what are you going to do next?
4.
Quarter, yep.
And then an 8.
And then an 8. So this is decomposing a fraction into, this is a rotten problem by the way, a fraction into Egyptian fractions. You chose a half, why?
It's like the largest fraction with having 1 as the numerator.
Yeah, so you choose a half first because that's the largest one you can choose. Okay? So in other words, your algorithm is always pulling out the biggest fraction possible. Okay? This is developed in the 12th century by somebody called Fibonacci, and it's called the greedy algorithm for that reason, because it always pulls out the biggest fraction. Okay? Yep. So, here's a little challenge. I want you to try this one. 2/21. 2/21. Decompose it.
Just do
1/21
1
over
over
21.
21.
Okay? And try, yep. 4/21.
You can technically do that with all of them, can't you? Like if you had 3/10, couldn't you just do like 1/10, 1/10, 1/10?
Yeah, but they generally tended not to use the same fraction again. So why might they not have done this?
Because there was an odd number, you can't, it wouldn't work.
So why not this? Why not 121 plus 121? 1/21 plus 1/21?
It's odd.
That's one reason, but there's another reason. Why, for instance, would you not break up, say, 5/12ths as 1/12 plus 1/12 plus 1/12? Why not? Because you could break it up like that technically. But why would you not?
They're all the same.
They're all the same. And what was the thing you talked about in cooking earlier, Gabby?
Oh, that they only have the measuring cups. Like certain.
The measuring cup idea, right? That you only have maybe 1 cup that says 1/12, right? You don't have 5 cups
Well,
that say 1/12.
you could just refill it 5 times.
You could refill it, but maybe you want to keep the. That's something you could, but if you want to store the stuff, then you can't,
Yeah.
right? Or you might want to pour it into other things. So if you don't use the measuring cup idea, you have to break up 5/12. So how could you break up 5/12? Okay, so let's try 1/3 plus 1/12. Did you use the greedy algorithm there? Yeah.
Can you go 1/4 to 1/6?
Okay, let's see. 5/12, that's 4 over 12 plus 1 over 12. That works, yeah? So 1/4 plus 1/6. Does that work?
Yeah.
3 over 12 plus 2 over 12. The difference is this one uses the greedy algorithm, this one doesn't. Okay, this one uses the greedy algorithm,
What is
this
the
one
greedy
doesn't.
algorithm?
The greedy algorithm is the idea that you pull out the biggest fraction you can pull out first. Okay? You pull out the biggest one you can pull out first. So,